Okay, this is the Professor, CBMD PhD. It's a Thursday, November 2nd, 2023. It's 2:25 and 19 seconds, AM Eastern Standard Time. And today's research, quantum computers. So let's jump to it here. Blade, not great. Imperfect timekeeping. Place a significant limit on quantum computers. Date October 30th. 2023. Source: Trinity College. Quantum physicists show that imperfect timekeeping places a fundamental limit to quantum computers and their applications. The team claims that even tiny timing errors add up to place a significant impact on any large-scale algorithm, posing another problem that must eventually be solved if quantum computers are to fulfill the lofty aspirations that society has for them. It is difficult to imagine modern life without clocks to help organize our daily schedules. With a digital clock in every person's smartphone or watch, we take precise timekeeping for granted, although that doesn't stop people from being late. And for quantum computers, precise timing is even more essential as they exploit the bizarre behavior of tiny particles, such as atoms, electrons, and photons, to process information. While this technology is still at an early stage, it promises to dramatically speed up the solution of important problems, like the discovery of new pharmaceuticals or materials. However, quantum computers are still too small to be useful. A major challenge to scaling them up is the extreme fragility of the quantum states that are used to encode information. In the macroscopic world, this is not a problem. For example, you can add numbers perfectly using an abacus in which wooden beads are pushed back and forth to represent arithmetic operations. The wooden beads have very stable states. Each one sits in a specific place, and it will stay in place unless intentionally moved. Importantly, whether you move the bead quickly or slowly does not affect the result, but in quantum physics it is more complicated. Mathematically speaking, changing a quantum state in a quantum computer corresponds to a rotation in an abstract high-dimensional space. In order to achieve the desired state, in the end, the rotation must be applied for a very specific period of time. Otherwise, you turn the state either too little or too far. A quantum algorithm is like an app that runs on a quantum computer. It was already known that timing errors can disrupt individual quantum logic gates, which are the building blocks of quantum algorithms. The work extends this to full quantum algorithms, showing exactly how precise the clocks must be to achieve a given computational accuracy. Since here it gets worse for more complex algorithms, it will ultimately pose a challenge for quantum computers. And currently, the accuracy of quantum computers is still limited by other factors. For example, the precision of hardware components or the effect of stray electromagnetic fields. But our calculations also show that today we are not far from the regime in which the fundamental limits of time measurement will play the decisive role. The scientific team is quick to emphasize that the message is not entirely pessimistic because the problem could be mitigated in the future by designing clever error correction protocols. And this is the Professor of Space Technology, Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.